we are supposed to find the roots of this equation here. This is a quadratic equation with complex coefficient. But it does not mean that we cannot try to solve this quadratic equation just like how we have solved for all the quadratic equations that we have done so far, which means that in order for me to find the roots of this, I am going to try to make use of the quadratic formula. So z is going to be equal to minus b, minus of b, which is minus 2, plus or minus square root of b squared minus 4ac, 5 plus 5i. And this is going to be divided by 2 times of a. So what I have is going to be equal to 2 plus or minus square root of this is going to be 4. 5, I'm going to factorize it out. Combining with minus 4, it will be minus 20 of 1 minus I, 1 plus I. This was the reason why we should factorize out 5, so that I can have a 1 minus I, 1 plus I, a conjugate pair here. Then this is going to be divided by this, I'll just let it be. So I have this. So I have a 2 plus or minus square root of 4 minus 20. This multiplied by this, it is going to be the real square plus the imaginary square divided by 2 times of 1 minus I. So it will be 2 plus or minus square root of 4 minus 20 times 2, 40. So 4 minus 40, it is minus 36 divided by 2 times of 1 minus I. And square root of negative 36, I can rewrite it as square root of 36 multiplied by square root of minus 1. So this, we will divide it by 2, 1 minus I, which means that what I'm looking at here is going to be 2 plus or minus this, square root of 36 is 6, and square root of minus 1 is I. So we have this divided by 2 times of this. So this divided by 2, it is 1. This divided by 2, it is 3. 1 minus I, which means that z is going to be either 1 minus 3i divided by 1 minus I, or z is going to be 1 plus 3i divided by 1 minus I. Let's multiply this by the conjugate of the denominator. Let's try to rationalize this expression here. So I'll multiply the numerator by 1 plus I and the denominator also 1 plus I. So for the denominator, just like what we have done here, the denominator will be 1 square plus 1 square. The numerator, 1 multiplied by this, it is going to be 1 plus I, minus 3i multiplied by this, minus 3i, this multiplied by this is going to be plus 3. So what I have is this and this, 4, this and this, minus 2i divided by 2. So this divided by this is 2, this divided by this is I. So one of the possible root is 2 minus I. Let's do the same thing for this. So I'll multiply the numerator and the denominator by 1 plus I divided by 1 plus I. So for the denominator, once again, it is going to be 1 square plus 1 square. As for the numerator, this times this is 1 plus I. This times this is plus 3i. This and this will be minus 3. So I will have a minus 2 plus 4i divided by 2. So we will have a minus 1 plus 2i as the other root.